Hello friends, the topic of today's video is construction of AVL tree for the given set of values. So what is AVL tree? AVL tree is height balance binary search tree where the balance factor is calculated for every node and allowed values for balance factor is -1, 0 and 1. So it should not balance factor should not be greater than 1 and should not be less than 1. So for every node balance factor is calculated and balance factor is calculated, that is height of left subtree minus height of right subtree. So this is how AVL tree is calculated. You can go through my video where I have introduced you what is AVL tree and what are the various rotation associated with AVL tree, that is LL, RR, LR and RL. So let us draw the tree step by step and then let us see various rotation. So 55 is the first node, since first value in binary search tree is always root node. AVL tree is also binary search tree. Then 66 is greater than 55, so it will come on right hand side. So again this tree is balanced. If you look, the height of this tree is 0, balance factor is 0 and it will be 0 minus 1 is -1. So tree is balanced. Then 55, 66 and then next value is 77, so 77 will come here because it is greater than 55. So again balance factor will be calculated, it will be 0, -1 and then -2. So again now if you look here, the tree is imbalance. So since the tree is imbalance, it is RR. Why it is RR? Because this is on right hand side, this is on right hand side. So in AVL tree we have to consider only 3 nodes. So this is, we have to take R and RO. So we have to take one rotation on left hand side. So what happens in RR rotation? The we have to move this node to left. Okay, so it will be 66, then 55, 77. Now the tree is balanced. The balance factor is 0, 0, 1 minus 1 is 0. Okay, so this is how the balance factor is calculated. Next value is 15, so it will be 66, then 55, 77, 15. 15 will be inserted on left of 55. So let us calculate again the balance factor. So it will be 0, 1, then 2 minus 1 is 1. This tree is balanced. So for 15 tree is balanced. Now next is 11. So I will put 11 here. Now we calculate the balance factor again. So if we calculate the balance factor, so it will be 0, 1 and 2. So this part, you have to focus on this part. This part is imbalance. Okay, so now what is the root? If you look here, this is LL, LL. So what we have to do in LL? We have to move this node to right. So it will be 66. Then since if we move to right, it will be 15. Then 55, 11, and then 77. So this is how the tree is balanced now. So if you look here, for it will be 0, then it will be 2 minus 1 is 1. Okay, so tree is balanced. Now next value is 33. So 33 will go to left hand side and it will come here greater than 15, so less than 55, it will be 33. Now if you look here, if we calculate the balance factor, it will be let us see whether the tree is balanced or not. What is the balance factor of this 0? It is also balanced, so it is 2 minus 1 minus 2 is -1. It is okay, but if you look here, E1, 2, 3 minus 1, 1, 2, 3, sorry, 1, 2, 3 minus 1. So balance factor is 2. So this part is imbalanced. Now in AVL tree we have to consider only 3 nodes. So here this part is imbalance. This part. 66, 15 and 55. So what is this rotation? This, if you look at, this is L and then R. So this is we have to perform LR rotation. So in LR rotation, what happens? The median value is always there here, root node. Okay, so which is the median value here? Median value is 55. So 55 will come here. 66 will go here, and then so it will be 55. 66 will come here, and then there will be 77, and then here 15, 11 and 33 will be on right hand side. Now the tree is balanced. Next value is 22. So if you look here, 22 will come on left of 33 because it is greater than 50, less than 33. So again calculate the balance factor. So 1, 2, 3. So here the balance factor is 3 minus 2 is 1. So right now the tree is balanced. So if you calculate the balance factor, it is 1 minus 2 minus 1, 0, 0, 1 minus 1. So right now the tree is balanced. Then next value is 35. So where will be the 35 accommodated? 35 will be on left hand side and right of 33. So again, if you check, the tree is balanced because here height is 0. Here it will be 1 minus 2 is minus 1. And again it will be 1, 2, 3 minus 2. 3 minus 2 is 1. So tree is balanced. Then next is 44. So what about 44? So 44 again will come to left hand side and it will go to 33 and it will be here. 44 will come here. Now if you look here, the tree is not balanced. That is, balance factor is not in between minus 1, 0 and 1. So let us see which part is not balanced. So this is, let us see which part is not balanced. So it will be 0, then minus 1, then 1 minus 2 is minus 1, then here it will be 1, 2, 3, 3 minus 1. Okay, so 1, it will be 1, 2, 3. Okay, so 1, 2, 3. So it is 1 minus 3 is minus 2. So this part is not balanced. So let us balance this part. So what will happen? So here if you look, which part is not balanced? This is right. So this is we have to consider only 3 nodes. This part is not balanced. 15, 33, 35. So we have to focus on this part. Now first of all, find out the rotation. Rotation is R and R because it is on right hand side. So in R and R, we move the this root node, this parent node, to the left hand side. So it will be 55, then 33, then 15, then 11. Okay, so 33 will come here, then it will be 35, left side 22, right side 44. Okay, and then it will be 66 and then 77. Now calculate the balance factor. It is 0. So again it will be 1, 2, 1, 2. It is 0, and then 1, 2, 3. 3 minus 2 is 1. So tree is balanced. So this is how the tree is constructed. So this is our final tree, final AVL tree, and this is how the rotation are performed in AVL tree. So I do hope you understand this topic. If you like the video, then please subscribe, like and share. Thank you.